实际上，我真的是非常高兴来参加晚上的活动。通常我们会说 "It's a great pleasure and honor"， 不过对我来讲是真的哈，因为我很久之前听过江教授讲星星看星星，我觉得实际上是太有趣了。所以当我看到这个公告的时候，我决定回信说我会来听。So that's why I got the job assignment 因为我说我要来听，他就说那我来 host。不过 really for me it's really a great honor and pleasure to host the speaker who you are really interested in。所以我真的很高兴来参加这场活动吼。那实际上翁主任给我 job assignment， 他给我一张背景吼。不过他刚才特别提到的一件事情，感谢中华精测。不过刚才翁主任已经提了。不过我想这个通识教育中心因为办这系列的活动上是非常有趣的。我们知道上学期讲达文西，这学期讲沈括，那我想都是非常有趣的一个活动，非常重要的活动。那刚刚最主要讲的是今天那个蒋国金教授哈，那他说他今天会用英文演讲，我不好意思，他说 Probably you can understand English better than his Mandarin 然后他今天的名字是梦溪话穹苍。那他跟我说他今天没有要讲这个星星，然后讲播还是跟讲天文。那我就讲一下江国金教授哦，他实际上是香港出生，然后他在香港理工应用数学系毕业，然后从1987年获得硕士学位。我记得那时候他还特别讲他以前怎么看星星。香港不是一个好看星星的地方哈，但是所以也因为这种样子，所以反而养成喜欢看星星的特殊的努力哈。所以我想这个是为什么他后来会走上天文，然后1997到英国牛津大学获得他的博士哈。那其他我想就不用念他的这些论文。那2007他就到了清华，然后他研究这些高能天文上做的真的非常的杰出。那2008年那时候台湾的我们学校的媒体要介绍他观察到来自超新星爆炸 X 光然后他有一些成果，这些成果当然后来让他得到不少的奖，包括了叫金我记我的名字，不要把这奖念错，叫年轻金鱼学者奖哦。所以我想他在他的研究上面表现非常杰出。那实际上他的中文虽然带点腔调，但是像他演讲来讲，另外演讲是非常的杰出，做得非常好。那我相信他今天用英文讲，应该会比他中文演讲讲得更有趣哦。只不过用英文讲这个古代的历史，这件事情这种双边的挑战实在是很高。这是为什么？我不敢用英文介绍这个实在是太挑战性没有准备上太高一点点。不过我们真的很高兴今天有机会来听江国金教授的演讲，那我们就再次欢迎江教授，谢谢。
So thanks for inviting me to this talk, and this is a very special talk. So when the General Education Center invited me to introduce this person, okay, I know about his contribution, mostly in astronomy, and I know he is very capable, okay, but that's it, okay, because, well, for me, I use the most advanced telescope to do the observations, so why bother his contribution, okay? But anyway, I thought it's a good opportunity to introduce a outstanding scientist to everyone, and so I take this challenge and then prepare the talk. And it turns out that I need to prepare quite a lot. Okay, I need to read a lot of articles written by him. Okay, and all of them are 古文. Okay, luckily, although my spoken Chinese is very bad, okay, I studied Chinese literature in high school, so it helps a little bit. Okay. So anyway, so today my talk will be mainly concentrate on his contribution in astronomy and science. and science mostly about physics. Okay,沈括is actually is really a multi-talented scientist, or he's not only a scientist, he's also a politician. He's also good at art. Okay, so science is just one of his many talents. Okay, and when I read his article, okay, I realized that it's very difficult to find someone in the world, even now, okay, to master his job. Okay, so I will introduce more about his contribution in this talk. Okay, so the English title is more obvious for you. Okay, it's basically about the universe. Okay, and the Chinese title is more fancy, and probably you may not know what is 夢溪. Okay, or if you look at this big poster, 夢溪筆談. Probably you don't know what it is if you don't know this guy. Okay, so this is one of the many works, okay, of沈括, and this basically summarized. It's more or less like it's written just before his death. Okay, so basically just a summary or reflections of his life, contributions in many different areas. So in this talk, okay, although I talk in English, okay, you will see a lot of Chinese, okay, but they are in Guan. So you may need to take some time to digest what it is. Okay. So let me just give a very quick summary of his contribution. So because we have a series of talk. Okay, so if you're interested in his work, I encourage you to come here to listen other talk as well. So basically, his talents actually start from his very young age. Okay, so basically when he was very, very young, he read a lot of books. Okay, so he is already very clever at the young stage. But the real talent, okay, is coming when he joined the government in the Song dynasty. Okay, so there's a story behind that, because in ancient China and in the Song dynasty, so if your father is a civil servant in the empire, okay, after your father passed away, so you will become the officer in the government. So basically, it just passed one generation to another generation. Okay, so his father is just one of the civil servants, okay, working in the government. Although the rank, I believe, is not very high-ranking officer. But anyway, after his father died, okay, so he joined the government in 1054. Okay, and again, it starts with a very low-ranking positions. Okay, and he joined the government in 1054. And here, just remember this year. And probably, if you are from Astronomy Institute, you know why you need to remember this year. Okay, so at the end of the talk, I will ask you why. Okay, and tell you why you need to remember this. So at the beginning of his career, he mostly responsible to agriculture and water control, okay, to improve the farming of the countries. Okay, and the most important thing in his career is in 1063 when he 中进士. So this is a very, if you know a little bit about the ancient examination system in ancient China. Okay, so this is a very important job. Basically, whenever you get this, okay, you can become a very senior officer in the government, very important people in the government. Okay, so this is a really important thing. So of course, after he get this, he by default he become a senior officer in the government, and one of the very first drops, okay, is to become 西天剑. So basically, it's a using today's language, is the head of the astronomy world, or if you want to really compare with the Western world, okay, so in the UK we have the Astronomer Royal. Okay, so basically he is the Astronomer Royal in the Song dynasty. So why bother astronomy? So in a moment I will tell you why. And in fact, astronomy or astronomers are very important in ancient China. Okay, not like nowadays. I'm an astronomer, but well, I cannot affect the government much. Okay, but at that time, it's really a serious business. Okay, so I already talked about the 夢溪筆談. Okay, so basically, so today the talk will be concentrate on the contribution from this work. Okay, and I will also suggest you to take a look. It's not a long work. Okay, and you can just pick up some interesting sessions to read it. Okay, so why astronomy is important in ancient China, or I can say in every civilization. So, for example, in Egypt, okay, in India, they all have a very good astronomy in the past. Okay, so one important thing about astronomy is that we can develop and set up the calendar and to tell you the time. This is a very important thing in the ancient world, because nowadays, of course, we have the clock. Okay, we can easily know the time, but consider 1,000 years ago, how can we tell the times? Okay, how can we know what is the day it is? So it is very difficult, and it is also important because, for example, if you're a farmer, you need to know, okay, when to do the suitable thing, okay? And if you need to travel, once again, also you need the time, okay? Otherwise, you will lose your directions, okay? So that's why it is very important in the ancient world, okay, to develop astronomy. One way to develop the calendar is to observe the objects in the sky, okay? Because we have a more or less like a clockwork in the sky. So we know that the sun, the moon, they will just rise from the east and then eventually set in the west. Okay, so they have a pattern. So we can use it as a clock. Okay, so that's why if you have enough observations, enough data, you can develop some kind of calendar or system to tell you the time. Okay, so that's why in almost every civilizations, they have many different methods, okay, or even build something very beautiful to tell the times. Okay. And in ancient China, we also have a belief is that the sky and the human being has some certain kind of connections. Okay, so whenever something happens in the sky, it will affect human being. Okay, of course, other civilizations may also have a similar thinking. So that's why being an astronomer is important. In addition to develop the calendar to tell you the times, they can also tell the king, okay, what he should do. So for example, so they can do some predictions. So for example, they can relate to some event, for example, solar eclipse, okay? Or maybe something happened, there's a new star in the sky, okay? And then the astronomer has to tell the king what to do. So imagine that if you know nothing about science, if all of a sudden during the daytime the sun disappears, what will you do? And then suddenly I come out and tell you that, okay, there's something will happen. Okay, then you may believe. Okay, even nowadays in Taiwan, in the Chinese communities, those fortune tellers telling you to do something. Okay, and of course not all of us will believe that, but some people really believe them. Okay, so in the past, the king also the same. So whenever the astronomer tells them to do something, they may act accordingly. For example, to go with a war with someone, okay, or to do something. Now, of course, they are very senior, and at the same time, if you say something wrong, okay, you may lose your life. Okay, so there's, but anyway, astronomers are very senior staff in the ancient China. Now, the calendar, of course, in practical way, we can tell you the times, okay? And also, the other thing is about the symbol of power, okay? So it's not surprising that if you look at the history, okay, especially in China, okay, for every dynasty or every king, okay, they may develop a new calendar because it shows the people that, okay, I'm now the new rulers, okay, of these countries. Okay, so everything has to be new. So that's why it's really just a symbol of power to tell people that I am the new king. Of course, for the practical thing, I already told you something, for example, farming, and also for taxations, to tell people when you need to pay the tax, and of course, the navigations to go somewhere. Now, all this about calendar and the time, we need to do a lot of observations, and we basically follow the following sequence. Okay, so we have the start with the observations, okay, and then to figure out the patterns, okay, and then from the patterns you can develop some laws, okay, to justify these patterns, and of course we will make the predictions. Okay, for example, if you develop the calendar, you predict when the solar eclipse happens. Okay, so for normal people, they will just look at astronomer as a magician. Okay, why you can do that? Okay, of course they have a lot of data, theory to back up this. So they make the predictions and then to do observations again. We verify if the observation is good or not, and then to revise the model. And again, back to this loop. It's more or less the same scientific method that we are using now. So whenever you do science, we just follow these patterns. Okay, and then in the ancient China, whenever they develop the calendar, they also follow these rules. Okay. So that's why there's also a motivations why we need to improve the calendar. Not only just a new king, but also in practical way. So I will show you a moment about this thing. Now, one of the contributions from沈括is to develop a new calendar. And basically, throughout his career, okay, he just built up one calendar. This one, 奉元曆. Okay. And this calendar is, again, it's very similar to other Chinese calendar. So if I'm not sure whether you're familiar with the Chinese calendar. Okay, so even nowadays we are still using that. So many people just call it lunar calendar. Okay, 农历. And just refer to the moon. But in fact, it's not correct. Okay, so ancient, the Chinese calendar or the lunar calendar that we are using actually is what we call the lunisolar calendar. It's a combination of the moon and the sun. So that's why we have the yin yang he li. Okay, so for example, in the lunar calendar, we always use the phase of the moon as the to define the month. Okay, but also sometimes you will know that in certain year you need additional month, a leap month, 闰月. Okay, why? Because we need to match with the orbit of the sun. Okay, otherwise it will just complicate the whole system. Because usually, for example, during the spring, we are talking about from January to March is roughly the spring. But if you have an offset in your calendar, then your spring will shift. So, and the weather is completely different. So it will just confuse everything. So that's why people have to adjust. The lunar calendar, if you just purely calculate due to the lunar orbit, we need to calculate to match with the sun as well. So that's why we call it lunisolar calendar. Okay, so basically, in the history of ancient China, okay, or I would say before the establishment of Republic of China, okay, we are using this lunisolar calendar. Of course, if you know about the history, actually the first group of people in the Chinese community using the Western style calendar is Taiping Tengguo. Okay, so actually they introduced the first Western calendar in China. Okay, but anyway, one of his idea is that even in 1,000 years ago, he already has this idea, but that has never been used, this calendar. It's called a Xue Jili. So I will introduce in a moment. So basically this Xue Jili is exactly the calendar that we are using today. So basically he just gives up all the lunar thing about the moon. So for him, the moon is just some additional information. So basically, the clockwork is based on the sun. So in this way, he can develop this new calendar, but it was never used, okay, in China, only until almost 800 years later. Okay, now from now on, there will be a lot of Chinese articles. Okay, so they are based on this夢溪筆談. Okay. So I just, for example, in this is a few sentences about the Xue Jili. Okay, I only extract some of the most important sentences. Okay, because it's a little bit long for this one, so I don't want to show everything. Okay, but basically, as you can see, he already mentioned that for each year we have 12 months. Okay, and then when is the beginning of the year? He just used 立春 as the start of the year. Okay, and what else he mentioned? For example, 12 months, and some of the months nowadays we have 31 days, 30 days. Okay, and then we have 2 months. Basically, they have 30 days. Okay. And even he did that, this just happened once in the calendar. Okay, and using this format, basically the entire calendar will match with the 4 seasons. So it won't change. So just follow these rules, you will have, if it is in June, then it is summer. You don't need to worry about whether in June it is already shift a few months, whether it is winter or spring. So that is a pretty clever at that time. Now, but as I mentioned, this calendar was never used, and in fact, in his work, he lastly mentioned a very interesting sentence. Okay, so basically there's an entire paragraph about this calendar. Okay, so after almost at the end of the paragraph, he mentioned that basically if he implement this calendar, people must be very angry with him. So no one will use this. Okay, but after certain times, so 800 years later, it will be very useful. So he already predicted that in the future, this calendar must be a useful calendar. Okay, so he already predicted in 11th centuries. Okay, so it's pretty amazing. Okay. So I find that when I read his work, he always have some comment or suggestions near the end of the article. And some of them are pretty interesting. Not only the science probably we all know about that, but some of his comments really interesting. Okay, now I want to show you a preview of a movie. Now, but this movie is a Japanese movie. It's not about the Chinese calendar, but the idea I want to show you this movie is that this movie is about a revolutions of or development of calendar in ancient Japan. So probably many of you know that Japan is influenced by Tang Dynasty. Okay, very much. Okay, so in fact, for a long time, the ancient Japanese used the calendar developed in Tang Dynasty. Okay, I think for almost 800 years. Okay, now the problem is that after a long time, so in this movie, I think the setting is roughly in Ming Dynasty, corresponding to the Chinese, is about the Ming Dynasty. Okay, but they are still using the calendar developed in Tang Dynasty. Of course, there must be a huge error, okay, in the calendar. So at that time, they want to develop a new calendar. Either use some of the more advanced calendar developed by the Chinese, okay, because it's already in Ming Dynasty. We actually have a very good, in ancient China, we already have a good calendar system. Okay, or they develop their own system. Okay, so during the movie, you will see that how we can do that. Of course, just go through the cycle that I mentioned to do the observations, to compare with the real observations, to revise and to check whether which calendar is good. So they have several candidates. Okay, so after that, the conclusion is that all the calendars from the China is not good for them. So at the end, they develop their own calendar.
"星好きなこの男に託された大計画。
暦がずれている。
お主に改暦の儀を命ず。
私は一介のご内に過ぎず、そのような大名は。
天を相手に真剣勝負を見せてもらおう。
ああ、わかんなくなった。測り直しですよ。私たちが小さいのではない。世が大きいのだ。天はさらに広大だ。
されば水戸が助ける。
多くの民の前で白黒はっきりさせましょう。
暦は帝の司る聖域だ。誤謬は許されんぞ。
はっ。お職にございます。なぜ不吉じゃ。日の軌道がずれている。
天意は使える我らにしか推し量れんよの。
いよいよわからぬ。なぜまた外した。
弱音は禁物でございます。
お前に何がわかる。
あなたのなすべきことはわかります。
天の定石を正しくつかみ、天地明察を成し遂げなければなりません。
時事歴を切れ。安い三節石。
800年の歴史をひっくり返す挑戦が今始まる。天地明察。
どうか私より先に死なないでください。
Now you have some idea how the ancient people work on the observations to improve the calendar. And in the movie, you may also see some ancient astronomical instruments, for example, like this. This is called a Huanyi. Okay, so of course this one is not, it's just a replicate one, and I think you can find a similar thing in many places in Taiwan. So for example, I think this one is 工艺科学馆 in Kaohsiung. Okay, and I believe you can also find similar thing in Taipei 天文馆 and also Taichung 自然科学馆. And they also have the similar thing, and I think that the one in Taichung is really a big one. Okay, and And these instruments is to basically help the astronomer to measure the positions of the star, to tell the location of the stars, such that they can have a better positions to do the calculations. Okay, so this is one of the very important instruments in the ancient astronomy. And沈括also developed, he basically, based on the previous design, and improved the capabilities of these instruments. So he actually has a book about these instruments. Okay, so he spent a lot of time on investigating how to improve it. Okay, so for example, on the right-hand side, you can actually also see the similar thing, the Huanyi in the band note of the Bank of Korea. So basically, they are using the principle is more or less the same. Okay, now again, this instrument is not a telescope. Okay, once again, it's not a telescope. So they can only tell the position of the stars. So at that time, it's just well before the inventions of the telescope. Okay, but still we can measure many bright stars in the sky with this ancient equipment. Now, by using this kind of equipment, of course,沈括spent a lot of time on observations, and I found that he's really hardworking. So if you are from Astronomy Institute, you should learn from him. Okay, you should learn from him. Okay, there are several very important messages from his article. So, for example, this is about the measurements or the observations of the polar star or the northern stars, 北极星. Okay, so we now all know that 北极星 is basically in the north directions. Okay, and but 1,000 years ago, people thought that it must be in the true north. Okay, just it's in the north, at the north positions. Okay, but using more precise observations, so basically he just look at this northern star, the Polaris, and then to observe every night to locate the positions of the stars and to see if it remains at the same positions. Okay, if not, it means that 北极星 is not at the true north. Okay, so let me just, there are several sentences which is pretty interesting. So by doing these observations, he already knows that this Polaris, the 北极星, is about located at about 3 arc degrees from the true north. Okay, so that is not exactly at the north. Okay, so and then he just mentioned how he make the observations. Okay, so basically every night, so you can see that every night basically he need to observe at the beginning of the night, in the middle of the night, and then end of the night, they make the observations. And then in the following 200 days, basically every day, they make the observations. And then at the end, he concludes that 北极星, the Polaris, is not in the true north, and he also estimates the angle or the distance from the north. So he is really hardworking. Now, if you don't understand this, I show you the pictures, then you will know. This is a modern pictures I took at the Newland Observatory in Taiwan. Okay, so this is the largest telescope in Taiwan. So at here you will see these stars. The laser pointer doesn't work. So this bright thing here is the Polaris. Now you see that it's not, if it is really at the north, it should be just a point. But instead, you see it's moving around, move a little bit, because I took these photos for about 5 hours. Okay, so it just traced this small trajectory. Okay, only five hours. Now, if you just follow his suggestions, and then do it 200 days, you will have a much better understand it. But basically, this is the picture that we have. Okay, the loft density is not at the real loft. Okay, but anyway, by doing this, he can really pinpoint the directions, because whenever we want to develop something to describe the motions in the sky, we need the directions. Otherwise, we don't know what to do. Okay. Now, after he discovered the offset of the Polaris, okay, his second job is to look at the magnet. We know the compass, okay? We all know the compass, and then just look at the needles, and then we know the loft. Or nowadays, we have the digital compass in your smartphone, then we can tell where is the loft it is. Now, probably if you are not in the earth science, okay, you may not know this, is that what we are measuring from the compass is what we call the magnetic loft. Okay, it's not the true loft. So if you look at, for example, this poster or this diagram, so it turns out that the true loft and also the magnetic loft has a small angle, a small offset. It really depends on the distribution of the magnetic field, okay? And because the inside the Earth is not a solid thing, okay? So it can change. So this magnetic field can change over time. So which also means that this angle, or in different locations, this magnetic loft will change. Okay. And so of course nowadays we have this knowledge. And in fact, I will show you in a moment that we can easily correct that. But at that time, okay,沈括basically just do the experiment to test this magnetic loft. Okay, so basically he just used the compass, okay, and then to check whether it is point directly to the loft or to the south, basically the same, okay. So, which means that he must know the true loft very accurately. How do we know? From the sky, from the star. I already show you the 北极星. This is more or less the true loft. Okay. Then he knows the positions, and then he measures the angle between the true loft and the needle. Okay. Then he can define this magnetic loft. Okay. And many people believe that he is the first one to discover this important thing. Why it is so important? Okay. If you look at your smartphone, okay, sometimes in some applications you can have, for example here, use true loft. Usually you just turn it on, okay. Then whenever you use the compass, it will point to the true loft. The reason is that it will calculate according to your locations about the offset between the true loft, and this is called the magnetic declinations. Okay, so for example, here in Taiwan, it's about minus 4.6 degrees now. Okay, and so you can also do an experiment is that you turn it off. Okay, so if this is an iPhone, if you just turn it off, you can do the same thing. You will find the offset. So this is very important, because otherwise you will point to the wrong directions. Okay. Now the question is. It is a very, actually, I just discovered a few days ago, okay, when I researched about his work. Okay, it turns out that沈括may not be the first one to discover the magnetic loft. And it seems that no one, if you just Google it, probably you don't get the answer. Always said that if it is in the Eastern world, must be沈括. In the Western world, Columbus. Okay, and we accept that basically the沈括is the first one, okay, and 400 years before Columbus' discovery. But a few days ago, I found that there's an article in Nature, and they researched the previous record of magnetic loft, and it turns out that probably we already have this idea in Tang Dynasty by another very famous astronomer at that time, Yixin. So he is one of the very famous astronomers in the ancient Chinese. Okay, so, but unfortunately, well, this is a very short paper. If you are interested, you can just take a look of it. However, there's no written record of the observations. Okay, so basically, the original record is lost. Okay, and so I cannot really verify whether it is true or not. Okay, so if it is true, which means that we discovered the magnetic north is even well before. Okay, so this is a table that in the paper. So basically, this first observation done in Xi'an, so in Tang Dynasty. And if you look at this table,沈括will be around here, 1086 here. The observation is made in Kaifeng. Okay, and it's not surprising because at that time, the Song Dynasty, the capital is in Kaifeng. Okay, but if you look at the time 1086 is basically沈括is already retired. So this observation must be made by someone else. Okay, but of course,沈括already had some record and maybe they already set up some instrument to measure this magnetic north, and then subsequently there are also other observations. Okay, but the conclusion is that maybe someone else, for example, Yixin, may be the first one to discover the magnetic north rather than沈括. Okay, again, he's a very hard-working astronomer. Here is another example. Okay, so this is about to revise the calendar. So as I mentioned earlier, one of the major works of沈括is to revise, to develop new calendar. So of course, in order to do the calendar thing, you need to observe the stars in the sky to check the pattern, okay, and then to do the calculations. So here is just describe how he can do that. Okay, so basically, so here the first 3 sentences just to tell you that in previous calendars, all the calculations just they don't have the observation to support the calculation. So they just calculate and there's no data to support the data, to support the calculations. So he proposed that in order to improve the calendar, we must do the observations. And again, every night during the sunset, before the sunrise, in the middle of the night, we need to measure the locations or the positions of the moon and the planet. Wuxing is basically the 5 planets in the skies, okay, that we can look at it with eyes without telescopes. And then here we need to keep a record, not just look and then that's it. You need to keep a good record, okay, for 5 years. So probably if you're doing a PhD, it's already a long time, okay. But it shows that it's hardworking. Okay. So he also mentioned that during these 5 years, because not every day is clear sky, right? And so if just remove some of the bad weather, so basically the effective data set is about 3 years of data, corresponding to 3 years of data. And not only that, after that, we need to do the calculations. Okay, so in today's language, what it is? Big data. Big data, so you accumulate a lot of data. Okay, and then at the end, you need to do the calculations to develop some method, develop some idea based on the data. So this is the important thing. Okay, now, I try to find someone, okay, in history to compare with his work. It turns out that almost impossible. The closest thing that I can find is these 2 guys. Okay, so if you study science, engineering, you probably know who is Kepler. Okay, we have the Kepler's law. I will mention it in a moment. Okay, and Kepler's at that time, okay, we are talking about 17th century. 16th, 17th centuries. Okay, and Kepler at that time is an assistant of Tycho. Okay, so he is also another very famous astronomer. And in the Western world, he is basically the last one who studied astronomy without telescope. Okay, because at that time before Tycho, okay, basically we can only use some very simple instrument to measure the position of the sky, only until the telescope developed in 1609, okay, used by Galileo. Okay, then we have another important period in astronomy. But anyway, what Tycho is working is basically very similar to沈括. He is supported by the empire, okay, and then he has his own observatories. So he has a lot of data about the motions of planets. Okay, so he collects a lot of data. So because he's getting old, and then he wants someone to process the data, so he hired an assistant. Kepler is his assistant. So using his data, Kepler developed the very famous Kepler's law. Basically, it's the motions of the planet. Now, back to沈括. He actually know about this. Now, this is another few sentences about his observation about or interpretation about planet. Okay, so basically, here he's mentioning about the Wuxin, again, is the planet. Okay, he measured the positions and he roughly derived the orbit, how it looks like, okay, of this planet. It's just like a willow leaf or 柳叶, like this one. So certainly, if you know about these leaves, it's elongated. You never see such a thing as circular shape. Okay, so he already know that the motions or the orbit of the planet will follow this kind of shape. Okay, an elongated shape. And not only that, he also noticed the travel speed. Okay, so for example, he mentioned that when it is in the middle, it goes faster. And if it is in the two ends, okay, it will move slower. He already noticed this pattern. It looks very complicated, okay? But if you look at this, this is Kepler's law, developed by Kepler based on data from Tycho. And basically, the first major conclusion is that the orbit of planet is an ellipse. So it's not a perfect circle, it's an ellipse. So basically, similar idea. And then the movement of the planet will look like this. Okay, it's just to help you to visualize if you are not studying physical science or mathematics. So basically, it's just to tell you that at different positions of the orbit, the planet will move, the speed will change. So sometimes it will move faster, sometimes move slower. So this is what we call this, the second law of Kepler's law. And this few sentences basically already cover this. So that's why I have to say that沈括is very clever. So he already combined the two masters in ancient astronomy in the Western world. Okay, here is another very interesting record. Okay, so it's about a meteorite. So basically, meteorite is something that is basically just like stone, and entering the atmosphere, it burns. Okay, so it emits very strong emissions, and then because we have the atmosphere, if there is still something not burned out, you can grab it from the ground. So this is the meteorite. And he has a description of an event, and I think it's very interesting because it describes basically every moment about a meteorite. How, for example, how it entered the atmosphere and what you expect. So, for example, you hear the sound, okay, and then it's a very big thing, okay, and then it moves around. Okay, so from one direction to another direction, and then we have a second sound in the sky, And then after that, the thing just dropped on the ground, okay? And then they try to look at what it is. So basically, they just go there and then to figure out where, what it is hitting on the Earth. So he just mentioned some descriptions of this remnants. So for example, it's still very hot. Of course, something just dropped into the atmosphere is burned. So of course it's hot, and also the size, and even the color looks like iron. Okay, so it's a very accurate description of a meteorite. So if you have a difficulty to understand this one, okay, I'll show you the video. So this is a video taken in 2013 about a similar thing. So there's basically a big stone about maybe 20 meters in size, 10, 20 meters in size. It's just burned. It's during morning. So you can see a huge thing across the sky burning. And then how powerful it is? This one will show you how powerful it is. So again, you see this fireball across the sky, and then it will create a shock wave. Okay, you will see here is some CCTV inside. It's just a moment when it's just exploded. So it's quite powerful. So now we know that this is the meteorite, basically just like a stone, okay, on the ground. So coming from the space. For smaller thing, if it's just burned entirely in the sky, it will call the meteor. Okay. So this is some of the sample that material and the surface features of this meteorite. And some of them can be quite large. For example, this is a very pretty large one, and I believe the沈括one is similar to this one. Okay, roughly the size of a hand. If you are unlucky, you will get hit by this meteor. And indeed, if the meteor is large, for example, 50 meters in size, it can create something like this. There's a crater in Arizona. Okay, of course, on the moon, we have a lot of craters. It's due to this meteorite. But luckily, on the Earth, we have the atmosphere to protect us. Okay. Last week, we have a very interesting, exciting science about the Japanese collect some sample from minor planet. So I won't go through this, but this is another way to collect the sample, okay, from the outer space. Okay. If you are interested, you can just look for the Hayabusa 2. It is a very, very exciting news last week. Of course, whenever we mention the meteor, the ocean, some of you may want to look at the meteor shower. And next, a few days later, there will be another major meteor shower. If the sky is good, you can take a look. Perhaps you can get a few meteors. Okay. Now, here is just switch the topic a little bit about the instrumentations. In my opinion,沈括almost developed the first telescope. Almost, okay, almost. But he already figured out the configurations of mirror, how to make things bigger, and also some concept about focal length and focus. So for example, he used different shape of mirror. So in this case, a concave mirror. Then he found that he can focus the light in one point. Okay. So he already has this idea, and also has idea with different shape. For example, instead of a concave, if we use a convex mirror, it will become smaller. So he has already some idea about this optics. And this is exactly the same principle used by Newton when he first developed the telescope using a mirror, okay, so which is about 600 years later. So again, it's a concave mirror, and then focus the light. So if沈括just move a small step further, okay, put something in the focus, he may already develop the first telescope. Okay, so in the last two slides, I would like to show you about the personality of沈括as a scientist. Okay, again, he's a very hardworking scientist, and he's very serious about science. Very, very serious about science, and very honest. But at least when doing the science, he's very honest. And of course, there's also in his political life, there's something else happening. But I'm not going to go through those stories. But anyway, in terms of science, he's really a good scientist. Okay, so for example, in this few sentences, so it's about the observations. So in ancient China, I already tell you that basically the department to observe the sky is the Xiding Zhen. Okay, and so of course every night they will do the observations and then report to the king. And so in Song Dynasty, they even have a very good system. So not only just one, okay, they also have an independent department. At that time, they call it Tenwen Yuan. So they are basically the two independent but identical departments. So they have the same instruments. So basically, the idea is that they can just cross-check with each other. So every day, they just report if they are doing the same thing. Okay, so to prevent cheating. Okay, so the system is pretty good. The system is pretty good. But of course, bad guy has their own method to bypass this. Okay, so it turns out that after certain times, okay, the two organizations, okay, you talk with each other on the table, okay, to tell you the answer. Okay, tonight I observed this thing, okay, and of course they will just basically copy the work, okay, so that they look exactly the same. And surprisingly, it's just a normal practice. So everyone knows about that, okay, so it's nothing, it's not a secret, okay, it's not a secret, okay. So that's why he doesn't make this idea. And many people, as I mentioned before, those astronomers, they are very senior people and they are very rich as well. So they just want the money, okay? And then they just make up all the observations. So once he became the head, so what he did is already fire 6 people, okay? Unfortunately, he also mentioned that after certain times, the system just back again. Okay, but anyway, so he is quite serious about how to do science. Okay, and he has his passions and philosophy. Okay, and this is another thing about his mentality. Okay, so this is again is about at that time. Again, because most of the positions in the government, so they basically pass from one generation to another generation. So it depends on the mentality of the next generations. So it happened that some of them may not be capable to doing the job, so they just earn the money but know nothing. So he already criticized this. Okay, criticized. There are many people doing this thing. So when he developed this奉元曆, okay, I already mentioned that. So he hired several astronomers, and one astronomer, this one, Pu, is one of his astronomers he hired, okay, to help him develop the calendar. Okay, and he is very capable. Okay, so from this message, he mentioned that he is very capable, okay, and basically because he is so clever, okay, people angry about his talent. Okay, so it's always happen. Okay, if you are too good, okay, someone will not be happy about that. Okay, And so that's why it will affect his career. Now, of course, he also mentioned that although the bad people cannot really do anything, okay, to this young astronomer, but it also affects his development. So the conclusion is that although沈括developed this奉元曆, okay, he's not happy about that because he thought that it's just like the previous systems. So that's why you see in this passage, okay, it's basically it can improve something, but not a perfect system. So he know about that. He know about that, and he feel very disappointed by people who work badly with his young assistant, Pooh. Okay, so that's why he has this message. So I think he's also a good mentor, okay, to inspire young people working on the science, good project, okay, but of course, not everyone will love this mentality. Okay, so I will stop here and welcome your questions. Thank you.
I think it's about time, so let's thank the speaker again.